In this part, we want to work on important ideas of math and related problems from prestigious exams, Stanford, Harvard, MIT. The syllabus that we want to work on are these 6 topics, and also simultaneously we will work on some math ideas, 2 ideas in polynomial divisions, quadratic equations, turning points, symmetry, about points or lines in functions, casework, small examples. And let me show you here. For example, we will solve some problem from British Mathematical Olympiad, Stanford Math Tournament, Harvard, MIT. Then we will solve a problem from last Math 2022, problem number 2. Then again, we will solve some other problems, for example, related to graphs, and from AMC, American Mathematics Competition. And then we will solve a related problem to math. Here, problems from British Mathematical Olympiad round 2. Another problem from Math 2022. Here, problems from AMC America. 3 problems and related problem from Math 22. And let me correct it. Sorry, this problem is from Math 2021. Okay, so let me correct it. 2021. Okay, or let me erase it. 2021 maths. Okay, so let's work on first problems. Okay, this problem from the UK, this problem from Stanford Math Tournament, and Harvard Math Tournament. So here, in first part, sometimes you need to work a bit on factorizing and something like that when we have especially positive numbers. In real numbers also it works, but because we want to solve next math problem related to number theory, again here we have whole numbers. So let's just solve some problems with that idea. Let's just start with this problem. Pause the video and try first on your own this problem. There are some identities you should memorize. For example, 1 squared, 2 squared, to n squared equals n times n plus 1 times 2n plus 1 over 6. 1 to n is n times n plus 1 over 2. It is so much famous. The next one, 1 cubed plus 2 cubed to n cubed, for example, is n times n plus 1 over 2. So we have many ideas like this. Next one, for example, a plus minus b whole squared is a squared plus minus 2ab plus b squared. Fourth idea is identity a plus, let me write like this. A cubed plus b cubed plus c cubed equals a plus b plus c times a squared plus b squared plus c squared minus ab minus ac minus bc plus 3abc. We will use it in Stanford Math Tournament. We should memorize. Next one again is easy. X squared minus y squared is x minus y, x plus y. We have also for x to the n minus y to the n, same idea. So if you want to learn all important ideas, feel free to send message to my WhatsApp number in the description comments. Now in this part, let's work on n squared minus 6n equals m squared plus m minus 10. Okay. In first step, let's write the solution of the problem. We say, okay, n squared minus 6n equals m squared plus m minus 10. Because I have n squared minus 6n, I want to use third identity. I want to write it something squared minus something. How can I do that? I can write n minus 3 whole squared is n squared minus 6n. It has plus 9, so we should subtract 9 to cancel 9. And for this part, it is m plus 1/2 squared. It will be m squared plus 2 times m times 1/2 m plus 1/4. So we will subtract 1/4 minus 10. Okay? Now, in next step, we will simplify and we multiply both sides by 4. So when we multiply by 4, inside square, it will be 2. So it will be 2n minus 6. Why I multiply by 4? To get rid of the denominators. Minus 36 equals 2m plus 1 whole squared minus 1 minus 40. Then we take these to left hand side, 2n minus 6 squared minus 2m plus 1 squared equals what? 36. It will be plus 36. It's negative 4, negative 5. Okay. Now here we can multiply by negative 1, then it will be 2n plus 1 whole squared minus 2n minus 6 squared equals 5. We've multiplied both sides by negative 1. Then we can factorize the left hand side. Why? Because of fifth identity. X squared minus y squared is x minus y times x plus 1. So if we use fifth identity here, we can write 2n plus 1 plus 2n minus 6. It's 2n plus 2n minus 5. And if we subtract, and so let's subtract 2m minus 2n plus 1 minus minus 6 plus 7 equals 5. And let's say problem says m and n are positive integers, okay? Because they are positive integers, 2n plus 2n minus 5, m has at least 1 and at least 1, so it will be 2n plus 2n at least 4 minus 5, it is at least negative 1, the first term. So if I want to write cases, it is 1, 5, 5, 1, negative 1, negative 5. We should check these cases. Okay, we don't need to check negative 5, negative 1 because m and n are positive integers. So let's check first case. If we write it, it is 2m plus 2n minus 5 is 1, first term, second term. 2m minus 2n plus 7 is 5. Now, if we add these two equations, 2n and negative 2n will be cancelled. 4m plus 2 equals 6. If we subtract 2 from both sides, 4m equals 4. And m equals 1. Now, if I replace m1 here, it's 2. Then minus 5, negative 3 goes right. Plus 3 plus 1, 4, n is 2. And also, if you check here, 2m, 2 minus 2n minus 4, negative 2 plus 1, 5. So first answer is this. Now, by the same idea, the same way, similarly, we check this one. Minus 5 is 5. 2m minus 2n plus 7 is 1. Again, if we add, it will be 4m plus 2 equals 6. So 4m equals 4, m equals 1. And m equals 1, 2 plus 7, 9. 9, we take it to right side, negative 9. 1 minus 9, negative 8. If we divide by negative 2, n will be 4. It is another answer. Last case, if we check 2m plus 2n minus 5 is negative 1, 2m minus 2n plus 7 is negative 5. So if we add 4m again plus 2, let me write it again. 4m plus 2 is negative 6. So 4m is negative 8, m is negative 2. So that's a contradiction because it doesn't work. Now that we've reached these, we work on main equation, n squared minus 6n. So our answers are what? m1 and 2, m1 and 4. So we want to check, always check at the end to not have any careless mistake. If n is 2, it will be 4 minus 12, negative 8 equals 1 plus 1 minus 10, negative 8. It works. Here, n is 4, 16 minus 24 is negative 8 equals negative 8. So we found two answers for these problems. Okay. It was one problem from BMO 1. We will solve this problem from Stanford Math Tournament and this problem from Harvard MIT Math Tournament. But let's solve first math problem 2022. and work with integers, then we will work on those two problems. Okay, this is second problem, Math 2022, first part 1. Suppose x, y, and z are whole numbers such that x squared minus 19 y squared equals z. Show that for any such x, y, and z, it's true that x squared plus ny squared whole squared minus 19 2xy whole squared equals z squared, where n is a particular whole number which you should determine. So let's work first on first part. Okay, let's start. We know x squared minus 19y squared equals z, but here it's z squared, so we know if we raise to the power of 2 x squared minus 19y squared equals z squared. Now expand left hand side. It is x to the 4 minus 38 x squared y squared equal plus 361 y to the 4 equals z squared. Okay. Now we know z squared also equals this. If we expand this, it is x to the 4 plus and 2n x squared y squared plus n squared y to the 4th minus 19 times 4 is 76. X squared y squared equals z squared. Z squared is what is x to the 4 minus 38 x squared y squared plus 361 y to the 4. It says for any such x, y, z, it's true that it is equal to this. So we want to see which n satisfies this. So x to the 4, x to the 4. It's okay, they are equal. For x squared, y squared, let's consider all terms related to that x squared, y squared, x squared, y squared. 2n minus 76 equals negative 38. And here y to the 4th, y to the 4th. N squared equals 3, the coefficient of y to the 4th equals 361. So n equals what from this equation? Plus minus 19. From here, 2n equals 76 minus 38, which equals 38. So n equals 19, and we want to satisfy both of them, so n is 19. Okay. So we proved this, and we found n is what number? Okay. Let's work on part 2. Part 2, it says find z if x equals 13 and y equals 3. Hence, find a pair of whole number xy with this value. Probably in these problems that we have different parts, we should use previous parts. So let's focus on part 2. Let's solve it in a new page. Okay, if x equals 13, y equals 3, the equation was what? X squared minus 19y squared. X squared minus 19y squared equals z. Okay? From this part. Now, x is what here? 13. So let's replace 13 squared minus 19y squared, which is 3 squared, equals z. Now, 13 squared is what? 169. So z equals 169 minus 19 times 9. 9 times 9, 81. We have 8. 9 times 1, 9 plus 8, 17. So 169 minus 171 is what is negative 2. Then it wants an answer for 4. As you can see from previous part, I said parts are related to each other. It says a formula for z squared. Let's copy and paste this formula. Okay. Okay, we said n is 19. So this one is n is 19. Let's replace. X is 13. Y is 3. Okay. So x squared will be what? Will be 169 plus ny squared is what? 19 times y squared, which is 9 whole squared minus 19 times 2xy. Okay. 2xy is what? 2 times 3, 6. 6 times x will be 6 times 3, 18. We have 1, 6 times 1, 6 plus 1, 7. 78 whole squared. equals z squared. Okay? Z squared is what? Z is negative 2. So it's negative 2 squared, which is 4. Okay? So we can consider, it says find another xy with this condition with x greater than 2. So this one is what is x? X is what? 9 times 19, as we've calculated, is 171. 171 plus 169. It's 0. 7 plus 6, 13. We have 1. 1 plus 1, 2. Plus 1, 3. 330 squared minus 1978 squared equals 4. So we will find, if we consider this equation, x equals 330, which is greater than 2, and y equals 78. Let me tell you why, for example, they say greater than 2, because maybe you can find some examples, for example, x equals 2, y equals 0. And then you don't need to use part 1. It says x greater than 2, then you have to do something like this, and the problem will be harder. Let me just correct something here. 171 plus 169 is 340. Careless mistake we had. The whole solution is correct, only we check careless mistake. Always try to check, okay, to make sure. I usually check and find these careless mistakes. Okay, so we found the solution of part 2. Solved. Part 3. Hence find the pair of positive whole numbers xy with x squared minus 19y squared is 1 and with x greater than 1. Is your solution the only such pair of positive whole numbers xy? Justify your answer. Again, we can use probably part 1 to solve this problem. Let's try. Okay, as I said, in problems of math, when we have different parts, we should use previous parts. We've solved 2 parts here. We found this is equal to 4. We want to find 1, so we can divide both sides by 4. And inside square, you should divide by 2. So 170 squared plus minus, let's call this one star. By using a star, we can save and divide it by 4 minus 19 times 39 squared equals 1. Okay, so we found one part. This part then it says, is your solution the only such pair of positive whole numbers? XY, justify your answer. No, because again by part 1, we can find another answer. How? Here we set the formula when we have in part 2, this part. Previous x squared, because then when you consider z1, z squared will be 1. 1 squared will be 1. Then here you can again say 170. Here x was what? X was 170. Y was what? Y was 39. Okay. So x squared will be 170 squared plus n is what? N is 19. We proved. Plus 19 times 39 squared minus 19 times 2 times x, which is 170, times y, which is 39 squared, equals 1. Again, from new x and y, you can create another x and y, and so on. Okay? Now it was part 3. Part 4. Prove that there are no whole number solutions xy to x squared minus 25y squared equals 1 with x greater than 1. As you can see, x squared is perfect squared, 25y squared is also perfect squared. And I told you an identity, fifth identity, when we have x squared minus y squared, subtraction of 2 perfect squares, we can factorize it. X minus y times x plus 1. Okay, so let's try. I can write it here. Part IV, x squared minus 25y squared equals 1. And then we can factorize x minus 5y, x plus 5y equals 1. And what are the cases? Negative 1, negative 1, positive 1, positive 1. And I want to find x. It says x greater than 1. So if we add these two equations, negative 5y and 5y will be cancelled. And 2x equals negative 2. So x equals negative 1 here, which is contradiction because x is greater than 1. Similarly here, if we add these two equations, x minus 5y is 1, x plus 5y is 1. Because they are integers, we can factorize because the product is 1. So if we add 2x, negative 5y and 5y will be cancelled, plus 1 will be 2, and x equals 1. Again, contradiction, because x has to be greater than 1. Okay, we've proved part IV. Let's work on part B. Find the pair of positive whole numbers. xy with x squared minus 17y squared equals 1, and with x greater than 1. Okay, here, what's the difference? Here we have negative 17y squared. Okay, because we have negative 17y squared, here we have negative 19. So in this part was 19. Now if we consider it for 17, let's see does it work or not. Suppose x squared minus 17y squared equals z. So we want to see, does it work if we change for 17 n to 19? We know z squared equals what? X to the 4 minus 34 x squared y squared plus 289 y to the 4. Now here, z squared equals x squared plus 17y squared whole squared minus 19. 2x, here it's not 19, it's 17. 17 2xy squared. Is it correct or not? So let's check. It will be x to the fourth plus 32 times the 34x squared y squared, which will be cancelled or not? No. So let's write plus 34x squared y squared plus 289 y to the fourth minus 4 times 17. 4 times 1, 4 times 8 minus 68 x squared y squared. If we subtract this and this, if we calculate, it will be negative 34, and these two things will be correct. Okay, now we can use this. It says we want to find 1. Okay, so because we have this formula for this part, if we reach also for z negative 1, it will be okay because we can find z squared. Now, if you want to work on x squared minus 70y squared equals 1, we want to find an answer for 1 or negative 1. Any of them that is easier. So, it's good that x squared be near to 17y squared. So, if x is 4, it will be 16 minus 17 times 1 squared equals to 16 minus 17, negative 1. It's good. It's z. So, x is 4, y is 1, z is negative 1. Now, if we use same formula, x squared plus 17y squared x squared plus 17y squared, then what? Minus 17 2xy squared minus 17 2xy squared equals z squared. So if you replace, x squared will be 16 plus 17y squared plus 17 squared minus 17 2xy. 2 times 4, 8 whole squared equals 1. So let's see is it correct or not. This one will be 33 squared minus 17 times 8 squared equals 1. So in this case, our main x and y are what? X 33 and y equals 8. And the problem says x should be greater than 8. And here we will see x is greater than 8, 33. Okay, so it is our answer and we solve this problem. Okay, it was this part. Now, let's solve these two problems. First, this problem is from Stanford Math Tournament, working with calculational things, identities. And also next problem from Harvard. Here it says, and from last SMT and HMMT. So problem 9. Let x, y, z be non-zero numbers, not necessarily real, such that x minus y whole squared plus y minus z whole squared plus z minus x whole squared equals 24yz. And x squared over yz, and pay attention, it says not necessarily real. X squared over yz plus y squared over zx plus z squared over xy equals 3. Compute x squared over y. When you want to compute something, for example, in most of the problem, you should calculate, for example, x, y, z. But here it's not x, y, z. So always focus, because sometimes you will solve this, but you don't pay attention and you wanna prove something else. So we don't need to find x, y, z separately. We only need to find x squared over y, z. So let's focus both on assumptions and sentence. So let's solve it in a new page. Okay, here, let's focus on first assumption. X minus y squared is x squared minus 2xy plus y squared plus y minus z squared, y squared minus 2yz plus z squared in last term, z minus x squared is z squared minus 2zx plus x squared equals 24yz. So if it's, let's simplify as much as we can. How many x squared are there here? 2y squared, 3z squared. So, and if we divide, so let's write first 2x squared plus 2y squared plus 2z squared minus 2xy minus 2yz minus 2zx equals 24yz. Now, if you divide both sides by 2, so it will be x squared plus y squared plus z squared minus xy minus yz minus zx equals 12yz. Now, if we take these to left hand side, x squared plus y squared plus z squared minus xy minus 13yz minus zx equals 0. Okay, so the first thing we've reached is this. So let's draw a rectangle around that. Now let's work on second assumption. Sometimes one of them is more useful in the beginning, so that's the reason we should work on both of them. Here I want to get rid of denominators, so I multiply, let me consider this one as a star. I multiply star by what? I should multiply it by what to get rid of uh, denominators? X, Y, Z. So I multiply both sides by x, y, z. So it will be what? It will be x cubed plus y cubed plus z cubed equals 3xyz. Now, I want to use this identity, memorize or take a screenshot from fourth identity. I want to use this. So as you can see, we know x cubed plus y cubed plus z cubed is x plus y plus z times x squared plus y squared plus z squared minus xy minus xz minus yz plus 3xyz. Okay, so we can cancel 3xyz from both sides, so the product of two terms equals 0. So the first one is 0, or second one. Let's do case works. Case works so much useful. X plus y plus z equals 0, x squared plus y squared plus z squared minus xy minus xz minus yz equals 0. So here, if we consider this part, let's consider this one double star. In second case, the left hand side will be 0. So we can conclude 12yz is also 0 right hand side. So if you divide by 12, yz equals 0. Okay, and if yz equals 0, pay attention to the thing we want to compute. The denominator will be 0. We want to calculate x squared over yz. So here we reached contradiction. Now, next part, x plus y plus z 0. Now here, because we want to calculate x squared over y z, we can write x in terms of y and z, negative y minus. Now we can use this one. Let's consider this one as 1. Okay, let's draw a circle around that. Okay, so in identity 1, we want to replace x with negative y minus z. So negative y minus z whole squared plus y squared plus z squared minus x. So minus x, it will be plus y plus z times y minus 13yz minus zx. So it will be plus z there times x. Negative x will be y plus z. We've applied negative on x equals 0 because of identity 1 or equation 1. Here, negative y minus z, if we want to raise to the power of 2, we can say plus plus. We can change the sign inside because when you raise to the power of 2, the result will be same. And then we can say it is y squared plus z squared plus 2yz plus y squared plus z squared plus y squared plus zy minus 13yz plus zy plus z squared equals 0. Let's simplify as much as we can. So y squared, y squared, y squared, 3y squared, z squared, z squared, z squared, plus 3z squared. How many yz? 2yz, zy, 3yz, zy again, 3 plus 1, 4yz minus 13 negative 9yz equals 0. We divide both sides by 3. It will be y squared plus z squared minus 3yz equals 0. Now, we want to compute what? What? X squared over yz. X squared over yz is what? X squared over yz. X is what? Negative y minus z. Negative y minus z whole squared over yz. Now, pause the video and calculate this part on your own. Here, because we want to reach to the power, we want to raise to the power of 2, we can say, we can write it as y plus z over y. So it will be what? It will be y squared plus z squared plus 2yz. Okay? Over yz. Y squared plus z squared is what? Is 3yz plus 2yz is 5yz over yz, which will be what? Which will be 5. Okay, so the whole solution is this. Should pay attention not to have careless mistake. Okay, so it was problem of SMT. We've solved BMO, SMT, Stanford. Now let's try this Harvard problem. It says suppose ABC are distinct positive integers and root A, root times root B times root C is an integer. Compute the least possible value of A plus B plus. They are distinct and positive integers. So at first, when you want to find minimum or maximum of something, try to say answers between two values. Okay, one part example, for example, if you find an example, which part is with example? It is important approach. If you want to learn all important approaches, as I said before, feel free to send message to my WhatsApp number in the description. Okay. What can we do on sides? Which side is with example? Which side is with proof? If we find, for example, an example that works here, because we want to find minimum, the answer will be at most that. This part we should prove for left side. Now, if you want to find an example, for example, one example is what? You can say C is, here it will be 1 to the power of 1 half times B to the power of 1/4 times C to the power of 1/8. So for example, one case, you can say C is 4, then it will be what? A to the power of 1 half times P to the power of 1/4 times C is 4, so it will be 2 to the power of 2 squared to the power of 1/4. So P can be 2. Then it will be A to the power of 1 half times 2 to the power of 1/4 times 2 to the power of 1/4, it will be 2 to the power of 1. Again, if A is 2, then it will be 2 to the power of 1 half times 2 to the power of 1 half. Look, the powers will be added together. 2 to the power of 1 over 2 plus 1 over 2 is 2 to the power of 1 over 1, 2 over 2. And it will be okay. So one case is this. In this case, A plus B plus C is what is 8. Okay. But maybe the answer is not 8. So that's the reason you should work on both sides. Now, let's see, can we find a better example? Here, do you agree we can say C is 1? Okay. If C is 1, then you can get rid of that. And it will be A to the power of 1 half times B to the power of 1/4. Then we can say B equals 4, so it will be A to the power of 1 half times 2 to the power of 1 half. Then A equals 2. So it will be 2 to the power of 1 half times 2 to the power of 1 half equals 2. So in this case, A plus B plus C is 2 plus 4, 6 plus 1, 7. Okay. Now it's 7. Because it says there are distinct integers, the minimum case is what? Is 1, 2, 3. We cannot have any sum less than this. So the answer is at least 6. So the answer is 6. If the answer is 6, we should find an example. So how can we find an example with this? when the sum is 6, we should find a good permutation of 1, 2, 3. So if we can't find, we can understand the answer is 7. Okay, so let's consider all permutations. A square root of B square root of C. So for each case we want to calculate it. Let's consider it is S. So A, B, C. If it is 1, 2, 3, S is what? A is 1, it is square root of. B is 2, square root of 3. Okay. If it is 1, 3, 2, then it will be square root of 3, square root of 2. They won't be integers. Why? Because you can say square square. When you take 2 inside square root, it will be 4. It will be 12. It will be 8th root of 12, which is not integer because 12 is not an integer to the power of 8 because 1 to the 8 is 1, 2 to the 8 is 2, 5, 6. So this one will be between 1 and 2. If you check other case, for example, this case, it will be square root of square root of. If you take 3 inside square root, it will be 9. 9 times 2, 18. So it will be 8th root of 18. Again, you can say same thing for this between 1 and 2. And you can do the rest as homework to prove all 6 cases. We have 3 factorial 6 cases to prove they are not integers. And so the answer, we proved the answer cannot be 6, at least 7. Also, we found an example which A is 2, B is 4, C is 1. So the answer is 7. Okay. So this problem was from Harvard MIT Math Tournament. We've solved related problems Stanford and BMO and math problem. Okay, let's work on next part. In this part, we want to at first pause the video and try on your own. For solving this part, it's good to draw a graph. It's so much useful in AME also, the exam after AMC, next round of AMC is AME. Drawing graph in many Olympiad exams, also in math, in CSAT, TMUA. Drawing graph can be used. Okay. Without drawing graph, you can also solve this problem. But first, let's draw a graph, then we can solve this math problem. Okay. So here, first equation is what? Is x squared plus 3y equals 9. Next one is something squared equals 1. For example, when t squared equals 1, what can I say about t in real numbers? Plus minus 1. So when this part squared is 1, so this part is plus minus 1. So absolute value of x plus absolute value of y minus 4 is plus minus 1. So it will be what? Absolute value of x plus absolute value of y. We add 4 to both sides. 4 plus 1, 5. 4 minus 1, negative. 4 minus 1, 3. Okay? So let's draw first absolute value of x plus absolute value of y is 5. Okay, we want to draw this line first. Okay. Let's focus on this. When x and y are greater than equal 0, here it will be x plus y equals 5. So pause the video and try to draw it first on your own. Okay. So here you say, okay, it is 5, and you should draw this line with a slope -1. So x5, y0, x0, y5. When we are here, it will be what? Here y-axis, x-axis. X is negative, so it will be negative x plus y equals 5. So x0, y5, y0, x negative 5. So here you should draw this line in this region, -5. In this part, x negative, y negative. So it will be negative x minus y equals 5. So x plus y is -5. Now, if y is 0, x is -5. If x is 0, y will be -5. Okay. And last part here, x positive, y negative. So it will be x minus y equals 5. So x is 5, y0, x0, y -5. Okay. So it will be a square like this. And now next level. We want to draw for 3. It will be same, but instead of 5, we should draw it for 3. Okay. Similarly, we can do same thing now. Here we've applied, we've drawn this. Now it's the time to draw this, and the problem says what? How many intersections do they have? How many xy satisfy both equations? It means how many intersections do they have? So I draw second equation with pink. Let's draw first one with another color. I will draw first one with blue. So here it will be what? Y equals 9 minus x squared over 3. Or we can say 3 minus x squared over 3. It is a parabola and we can say quadratic equation. Here it opens up or opens down. It opens down because negative 1 over 3 coefficient of x squared is less than 0. Okay. And when x is 0, we have turning point in y3 because it's the maximum. So it's 3, it's negative 3, it's negative 3, it's 3. Negative 3, it's positive 3. Okay, so it passes through this. The turning point is this. It is the first intersection. Now, if x equals 3 or negative 3, this part will be 9 over 3. Not 3 minus 3, 0. 3 minus 3. So y will be 0. So we will understand it passes through these 2 points. Okay. So we can continue like this. And we can continue like this. And now, how many intersections are there? Let me draw red around them. 1, orange, 1, 2, 3, 4, 5. So the answer of this problem is what? Is choice D, which is 5. This problem is one problem related to graphs and something like that. Let's focus on this problem of math related to drawing graph and also integrals. It says what? Sketch y. It says sketch y equals x squared minus 1 to the n for n2 and 3. And the same x is labeling any points that lie on both curves or that lie on either the x-axis or the y-axis. Okay, let's focus on n2 first. Y equals x squared minus 1 squared. Okay, it will be x minus 1, x plus 1, x minus 1 squared, x plus 1 squared. And in this part, let's also calculate y prime to find turning points, local maximum, minimum. And the points that the tangent line is horizontal, it will be 2 times x squared minus 1 times derivative of this, which is 2x. So it will be 4x times x squared minus 1, which will be 4x, x minus 1, x plus 1. 3 points for this graph are so much important. x1, 0, negative 1. Okay, so if x is 1 or negative 1, y is 0, so we can write it as like this. 1. We can also draw, because these points are important, let's write, for example, 1. And negative 1 here, and 0 is what? It's 1. Okay. And if you see this, the first one is local minimum. You can see before that is decreasing. And for example, if x is large negative number, this one will be positive and so much large. So it will be something like this. This one. It is this one, like let me draw like this and intersect this one and like this. Okay, so it was n2. Now let's focus on n3. Okay, for n3, y equals x squared minus 1 to the power of 3. It will be x minus 1 to the power of 3 times x plus 1 to the power of 3. And y prime is what? Is 3 times x squared minus 1 whole squared times 2x. So it will be what? It will be 6x times x squared minus 1 whole squared. Now, if I draw a table for y prime, x, y prime, what are the zeros? -1, 0, +1. So in these cases, y prime equals 0. Okay. Now, when x is so much large, obviously it is positive. When it is here, or 1, because it is look 6x, x minus 1 squared, x plus 1 squared. When you go from this one here, the signs here won't change, only here will change, but because we have square, only here will change, but because we have squared, it won't change, we give positive. For 0, it will change, it with negative, and this word also negative. Or you can say this word is at least 0, and in these, if it is not 0 in these parts, then it will be positive, and it is related to sign of x. So if you want to consider is decreasing, here increasing, and here increasing because positive. So in 0 it is what? 0 minus 1, -1. So let's move this word down, this word. Okay. Now we should select 1 here, and then it will be something like this. And because it is the power is 3, okay, we can conclude that it increased more. It will be something like this. And this part. And here it goes like this. And this part. Okay. But it's better to draw because they have another intersection. So let's check. Let's check to see all intersections, then we can conclude better. X squared minus 1 squared equals x squared minus 1 to the power of 3. So we can divide by x squared minus 1. So first case, x squared minus 1 is 0. So x plus minus 1, 1 intersection. If it is not 0, you can divide. It will be 1 equals x squared minus 1. So x equals x squared equals 2. So x equals plus minus root 2. Okay, so we have another equation, another intersection. So here we can find it better. Here, let me show. For this part, it goes like this, and you can find the derivative here or near 1. You can see that the blue diagram is on top of that. Then they have intersections. This x is root 2. And for root 2, it will be what? Root 2 is 2 minus root 2 squared minus 1 whole square is 1. Okay, so if you want to find better intersection, it's a better figure. Let's draw a better one. So it will be something like this. Let me draw or a bit better. Okay, and this part, it will be something like this. Okay. And the other diagram will be like this. Like this. Okay, so we found intersections. So, here, this part will be what will be root 2. This part will be what will be -2. And the diagram is symmetric with about y-axis. Okay. It says draw both of them on the same axis, labeling any points that lie on both curves. Okay, we found this point, this point, this point, 4 intersections, or that lie on either the x-axis and y-axis. Here, here. Okay, it was part 1. Let's solve part 2. Part 2 says without calculating the integral explicitly explain why there is no positive value of a such that this when it is even. Why? Because this one, when A is, for example, positive number. X squared minus 1 to the power of even is greater than 0 when x starts with 0. Only in x1 it will be 0, and in other parts it will be positive, so it cannot be 0. If n is greater than, because look, it starts the diagram. When x is 0, it will be what? It will be 1. Okay, and it is always positive. In 1, it will be what? It will be 0. So it will be something like this. And again, after 1, it will be positive. Okay, so integral, calculate the area. It is always on top of x-axis. So it will be positive. Now, next part. If n is greater than 0, is odd, we will write n equals 2m minus 1 and define am equals, am is positive, to be a positive real number that satisfies this. Okay. If such a number exists, explain why such a number am exists for each whole number m greater than or equal 1. Let's prove this. Okay, at first, when we start, when x is 0, it will be 0 minus 1 to the power of an odd number. So if we draw x-axis, it starts with -1. And it is negative because a negative number to the odd number is negative until 1. It will be something like this. And after 1, it will be positive. Okay. And it will be larger and larger, and it goes to infinity. So when we calculate the integral here up to this part negative, after that it will be positive, 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 but because it goes to infinity, there exists a part that this part equals this part, and that part we call it am. Okay, you should explain this. If you had question or wanted to learn important things or in any part you had question, feel free to send message to my WhatsApp number in the description comments. Here it says find A1. So if you want to find A1, part what IV? AM is what? N is 2m minus 1. So m is 1, n is 2m minus 1, which is 1. Okay. Integral from 0 to a1, x squared minus 1, dx is 0 to a1, dx equals to the 1. It should be 0. Okay, and now we should find a1. So here, this integral will be what? X cubed over 3 minus x from 0 to a1 equals 0. It will be a1 cubed over 3 minus a1 equals 0. Now, a1 we know is not 0 because the problem says it should be positive here. So we can divide by a1 because it's positive. So a1 squared over 2 minus 1 equals 0. So a1 squared equals -1 here, 1, 2. a1 is positive, so a1 is the square root of 2. We've calculated a1. Now here I wrote 3. I don't know why I forgot. Here is 3, so let me correct it. It's 3 root 3. Okay. It was IV. Let's solve next part. Part V. Prove that A2 is from between root 2 and root 3. Okay, so let's work on that. The A2y is between root 2 and root 3. For A2, it will be what? M is 2, N is 3. N is 2m minus 1 is 2 times 2, 4 minus 1, 3. And it will be 0 integral from 0 to A2, x squared minus 1 to the power of n, which is 3. Yes, 12 minus 1, which is 3. dx equals 0. Now again, by using identities, I told you you should memorize in the beginning of the video. You should also memorize binomial theorem. If you have a plus b cubed, it will be a cubed plus 3a squared b plus 3ab squared plus b cubed. It is binomial theorem. You should memorize to the power of n. If you want to learn all important ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments here. It will be x raised to 6 minus 3x raised to 4 plus 3x squared minus 1. dx equals 0. Now, here it will be x to the 7 over 7 minus 3x to the 5 over 5 plus 3x cubed over 3x cubed minus x. Okay. This one should be 0. We want to say the answer is between root 2 and root 3. Let me check. It says, okay. As you can see, we have only one value that it is equal to 0. Because before that and after that, here it is negative integral. Here it will be positive. So we can find only one answer. The problem says prove that it is between root 2 and root 3. So if in root 2 it is negative and in root 3 it is positive, then we can conclude AM is between them. So let's define this as f of x. F of root 2 is what? And f of root 3 is what? Root 2 should be positive. Root 2 should be negative, means it's still we've not reached 0. And here it should be greater than 0, means we pass from AM. F of root 2 is what? Root 2 to the 7 over 7 minus 3 root 2 to the 5 over 5 plus root 2 cubed minus root 2. Root 2 to the 7 is 8 root 2 over 7 minus here 3 times 4, 12 root 2 over 5 plus 2 root 2 minus root 2. Okay. And now, here, let's see what can we conquer. 8 root 2 over 7, we can write it as, let's write it here. Let me write it in another new page. 8 root 2 over 7, you can write it as root 2 over 7. 7 root 2 over 7 will be root 2 minus here. I write it as 2 root 2 over 5. 12 as 2 plus 10. 10 over 5 is 2 minus 2 root 2 plus 2 root 2 minus root 2. We can cancel this and this one minus root 2 plus root 2. And it will be what? It will be 35. 5 root 2 minus 14 root 2 negative 7 negative 9 root 2 over 35. Okay, so here we've proved what? When we start, let me draw a figure to understand better. It will be this, and we said, for example, in this part, it is A2, that this area equals this. So in root 2, it is negative, so we understand root 2 is before A2. Now let's calculate f of root 3. If we prove this, f of root 3, we want to prove root 3 is here, means we want to prove it's positive. It's root 3 to the power of 7. It will be, let me write root 3 to the power of 7 over 7. Minus 3 root 7 to the 5 over 5 plus root 7 cubed minus root 7. Okay. Root 7 to the 7, you can say, okay, root 7, if you multiply it 7 times, if you multiply root 3 7 times, each two of them will be 3. Okay, so 3, 3, 3. We have 3 3s. And 1 root 3 will be left. 3 times 2 is 6 plus 1 7. It will be 27 root 3 over 7. Minus 3. Again, here, why I wrote root 7, root 3, sorry. Root 3 to the 5, root 3, root 3. Okay, root 3 3 times 9, 3 times 3, 9 root 3 over 5. Plus 3 root 3 minus root 3. Okay, so it will be 27 root 3 over 7 minus 27 root 3 over 5 plus 3 root 3 minus root 3, 2 root 3. Now, in first part, I take my factor from 27 root 3, 1 over 7th minus 1 over 5th plus 2 root 3. Okay, we want to prove it's positive. 27 root 3, it's 35, 5 minus 7 plus 2 root 3. It's negative 2. And now we use common denominator 35. Negative 2 times 27, negative 54. Root 3. 2 times 35 is 70. It's 70 root 3. So it will be what? 616, 16 root 3 over 35. Okay, and this one is positive. Okay, so we prove this and we conclude that root 3 is after root 2. So a2 is between them. So we've proved parts. This one. Okay, we proved all these parts. Also this and this. How many parts are left from this problem? One part. It says without calculating further integrals, find the approximate value of am when n is a very large positive whole number. You may use without proof the fact that this one is less than 0 for any sufficient large whole number m. Okay. So let's draw here the figure. It says m is so much large. From in 0, it is what? 0, minus 1, negative 1. Negative 1 to the power of large number exactly is negative 1. But if x is a bit greater than 0, then this part will be from 0 and negative 1. Negative 1 and 0. And if you raise it to the power of large number, it will be near 0 but negative. Okay? So here it will be 0, negative. And they are near this part. Okay? So much near to 0. Up to what? Up to 1. In 1 it will be what? It will be 0. A bit greater than 1 it will be what? It will be, again, because it will be subtracted from 1, it will be between 0 and 1. And because you raise it to the power of large number, it is so much small. Onto the part that this will be greater than equal 1. So until which part is less than or equal 1? X squared less than or equal 2. X is less than or equal root 2. Okay? So here root 2 is around this number, but in root 2 it is what? It will be 1. 1 to the power of large number is exactly 1. But after root 2 it will be what? It will be greater than 1 and a bit greater than 1 to the power of large number will be so much large. Okay? So it will be so much large and it goes up and up. And because this part is so much great, this area, it can cancel all these negatives. Okay, and look here, it won't be 0 because the problem says, okay, from this part it is less than 0. So the answer is not this, but a bit greater than root 2. It is so much greater than 0. So the answer is a bit greater than root 2. And as you can see, it says approximate value of am. So am is around root 2, a bit greater. Okay, so we've solved also this problem, this part completely. The other parts from each topic, from each idea, for example, BM around to this problem helps you. I release the solution of some of them, and if you had question, I want to leave them as homework. If you had question, you can send message to my WhatsApp number. Then you can solve this problem of math 2022. Then this problem of AMC is so much good related to symmetry. For example, this function is symmetric about which of the following choices, and I will tell you how you can reject choices, how you can prove choices. So much important. Why? Because in this problem you can see, for example, we have symmetry of a graph about, but it is a simple problem, but you should learn these things. You can solve these problems as homework. This problem of AMC and divisibility in polynomials, it has two ideas. One part is you work on this bx qx plus rx and it has some points, and the other parts, for example, you have a polynomial. When you divide by, for example, x minus 1, the remainder is 3. When you divide this by x plus 1, the remainder is 2. And you want to find the remainder. You want to find when you divide it by x squared minus 1. It has a trick. It will be ax plus b. You can use these things. If you want to get good at these two tricks and you can you can solve AMC problems, last AMC problems, also MAT or math harder problems, like this problem and harder problems. If you learn these ideas, you can solve them. And if you wanted to learn these important ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so solve these problems as homework, and thanks.